Okay, so you should have seen this in the announcement as well, but just kind of want to clarify what's going on here. So I'm going to go through a few different problems from this work and for any other work we're doing, and then when I'm done with all of this, you'll have some additional problems if you want to practice those, and you will have to submit an exit ticket with a few problems to show you did everything for today. So we're actually going to start with number 4 here because this gets to a lot of the things that go back to what number 1 has and a few of the other problems have. So this is asking about measure of angle 2. So we know measure of angle 2 and measure of angle 4 are both 90-degree angles. We know this because tangents are perpendicular to the radius. Then our next one talks about measure of angle 1 is 40 degrees. So we know that 360 equals 90 plus 90 plus angle 1, which is 40 degrees, plus, we're going to call this x for this angle q in here, that measure of angle 3. We add this all up, we get 360 equals 220 plus x, so x equals 140 degrees. So then measure of angle 3, therefore, is 140 degrees. Next one's asking about arc AB. So arc AB is this arc here. So an angle 3 and arc AB are going to be equal to each other. So the measure of arc AB is just 140 degrees. And our final one, measure of arc ACB, we'll just do 360 minus 140. So we will get 220 degrees for arc ACB. So PB, we know that PA is 12, so then PB has to be 12 centimeters as well. So knowing what we did on number 4, on number 1, this 54 and W just add up to 180. So then W will be 180 minus 54. So W equals 126 degrees. We just need to subtract those two from each other. That's why we're getting 126 degrees. Okay, so on this next one, we know that PA and BQ are both perpendicular to this same line here, which means that PA and BQ are parallel to each other. Then, so what we need to find next is this angle here, because we know that this angle is congruent to angle BQX, which is what we're looking for. So since AMC is 295, CPA here is going to be 65 degrees. We got 65 degrees by taking 360 minus 295. So then BQX is also going to be 65 degrees. So with number 3, since these two circles share a common tangent of PQ, both this measure of angle NQP and the measure of angle MPQ, these are both 90-degree angles because the radius is perpendicular to the tangent, so these are both right angles here, which tells us that the quadrilateral MNQP is a trapezoid, and it's a trapezoid because these two lines would be parallel to each other because they're both perpendicular to the same line. Our last one here is asking us, so PA, PB, PC, and PD are all tangents. Explain why PA is congruent to PD. So our brief little explanation, you can write out a little bit more if you would like, is that so we know PA is congruent to PB because they're both tangent to the same circle from the same point. Then we can say PB is congruent to PC because these are both tangent to the same circle from the same point. Then PC is congruent to PD because PC and PD are both tangent to the same circle from the same point. Therefore, because of our transitive property of congruency, PA is congruent to PD. So that kind of is our explanation what we would use there. For 1 and 2 here, we would just be verifying the Pythagorean theorem, which we've done before, but we would just be checking if 9 squared plus 40 squared equals 41 squared. If this is true, then it's tangent. If it's not true, then it's not tangent. We're just trying to find out if GHI is a right angle, is basically what we're trying to do here. So we'd be verifying the Pythagorean theorem. If this is true, then it's tangent. If it's not true, then it's not tangent. As we move down here to 3, 4, 5, and 6, I'm going to go through 3 and 5, and I'll leave you 4 and 6 if you'd like to do those on your own. So number 3 here, we know that these two segments are congruent to each other, so we just set those equal to each other. We just set x plus 10 equal to 3x minus 6, and we could solve for x here. So we would have 2x equals negative, wait, I can do this. 2x equals 16, 2x equals 16, so then x would equal 8. On our next one, we would just use the Pythagorean theorem here. So we would say 8 squared plus x squared equals 17 squared. So 64 plus x squared equals 289. We subtract 64 from both sides. We get x squared equals 225. So x equals 15. So with 7 and 8, we're using these properties we've been using on a couple problems recently, in that two tangents from the same point are congruent to each other. So for instance, if this is 4, then QU is 4. If this is 13, then UR is 13. This is 9, that's 9. And then so we could say 2x equals 9, so x equals 4.5. And then after this, we can add up all of the numbers around the side. So 9 plus 9 is 18, plus 4 is 22, plus 4 is 26, plus 13 is 39, plus 13 is 52. So the perimeter equals 52. Then again, you can do 8 if you would like to do so. This second page here, I don't think you guys should do the second page. The constructions, don't worry about it. You can X that out. This next page is pretty good practice. If you want to try multiple things on the same diagram, practice doing some of the things we've done before. So this back of that page is pretty useful. I'm not really going to go over any of this together. If you have questions about it, feel free to ask me on our discussion page or via Canvas inbox message. Then our last page here are some challenge problems. I think they're interesting. Again, if you want to go through them, try them out on your own, and then ask me questions as we go further. Let me know either via discussion or Canvas inbox.